So today we'll discuss about the molecular symmetry and point groups. So here you can see, so the first one is symmetry, element and operations. We come across the symmetry practically in every sphere of human endeavor. So we appropriate suppose you could consider a butterfly or a leaf or flower or any building or a vehicle or a painting, a crystal, a snowflake, etc. due to their symmetry. So there are countless number of symmetry things we come across. Just look at a shape. So here you can see. So this is the shape of so one picture. So the figure given below, we show that the first three pictures are symmetrical, whereas the fourth one is not. So here the first one is symmetric. Why that is symmetric? You can see here this is the if we'll draw a plane passing across the image like this, so the left hand it just looks like the so right hand side of the plane. So that's why this is the symmetric axis passing through the plane, passing through the object. And similarly, the second object is also symmetric, the third object is also symmetric, but the fourth one is not symmetric. That means there will be no symmetric axis passing through the image. And similarly, we say that the first picture is more symmetric than the second one, and if you consider a sphere, and a sphere is more symmetrical than one cube, because in sphere infinite number of symmetrical axes are there. But in case of cube, for example, if you rotate the cube by 90 degree, 180 degree, and 270 degree, about an axis passes through the center of any of the opposite faces, or by 120 or 250, about an axis passes through any of the opposite corners. And if you rotate that cube through the axis, passes through it at 90 degree or 180 degree or 270 degree, then you will same appearance will there. So, but in case of a sphere, infinite number of axes can be there. So the infinite number of axes which will passes, infinite number of axes that will passes through the center of the sphere, so that by so rotating the sphere by any angle, same appearance will be there. So symmetry may be defined as the property of invariance of an object, system or structure under specific transformation. In simple words, an object can be called symmetrical if it can be changed somehow to obtain the same object. That is, when the object is rotated, reflected, or translated, it still looks the same. That means same appearance will be there. Then that is called symmetry. Alternatively, a body is said to be symmetrical if it can be divided into two parts and are related to each other in certain ways. For example, if we consider the vowels of the English alphabets, so here this is the A, E, I, O, U. So